this morning?
Tessier Edouard.
Wait 1 second. Yeah.
Russell.
Yeah. Anybody else? We'll see. I don't know. Maybe they will join us online. Maybe not.
Si, un friend community.
I have an experiment waiting. One of the famous yeah, alive. Need to switch. This can be close and let me appear online. It's one of the, let's say, black magic. One to introduce it was Theremin. Someone like Tesla in communications. Russian name was Theremin. In the United States it was famous as Theremin. Very interesting and strange person ended his life in reclusive in own chamber in Moscow in prison. Official was an enemy of the state. In reality was hiding from people working. Official, as official history tells, working on mechanical television. Nobody really knows what. Maybe someone knows, but it's covered with secrecy. He's one of the known works of Theremin was bugging of U.S. Embassy in Moscow. Huge wood carved United States seal was given to 1953, if I'm not mistaken. Great wood carving, but it was hiding a bug inside the microphone. And the genius, it was called the thing, and later presented in United Nations after failure of U2 with powers. US presented in United Nations. It has no power. Device was activated by radio beam from a nearby church. But this one that I'm showing is also very famous. Still produced in Japan is Theremin box, very popular in Japan. It's a nice demo for our today's. Oh, I cut myself. Come in, sorry. We have a day of black magic. Witcher? Yeah, couple years ago, students promised me an exorcist for this experiment. Yeah, it's a kind of black magic. Come here. Today we have a day of black magic, so. Okay. It's a funny toy, isn't it? everyday decompose thing. How it works? See, a lot of things here. You have parts, the screws are through one valve, something here. Okay. I'll try to explain it. What we got here. We have right part and left part. I'll start from the left. Plus 250 volts. One capacitor. Come here. Are you afraid of black spiders? They will get you. Yeah. Here is schematics. Where? People being late will become a subject of black spells. So, I draw a left part of my schematics. It has right part and left part. Here is the left part. Hey, can you explain the schematics? Yeah. Maybe you can try. Explain this. We saw something similar 2 lectures ago. Yeah. When I talk about systems with return, what do we have here? Linear amplifier. Yeah. Loaded with resonance circuit. And this is return via metal inductance. What we get as a result? This is positive return. Guys, what did we get? Linear amplifier, resonant counter, positive return. As a result, it will oscillate and oscillate in theory on one particular frequency, resonance frequency of the circuit. Because the circuit has a bypass characteristic like this frequency, it will allow only one frequency in theory. In reality, it will be short range. Positive return. As a result, we got what? One frequency, we have a generator of harmonic signal. Blue line shows the signal. Divider is needed because I need a small voltage. At this moment it produced 50 volts. I need 5. So it's, in reality, it's a second signal. Left side is a similar network. Similar. One moment, I'll draw schematics. Similar, but not so easy. You wait. So, something bad will happen. How this network works? One resonance contact. It's coupled as auto-transformer. And another one. The idea here to get better, more precise, more stable, let's say cleaner harmonic signal to use, in fact, in sequence to resonance circuit. If we connect in series two networks, let's say H1 and H2 transfer function, what will be the result? The multiplication, yeah? Result is equals to H1 multiplied by H2. So, one is not ideal. Second one also not ideal. But if multiplying them, we have better, more ideal. And moment, this one, the key element, this one determines most, say, has a stronger role in determining frequency, make more stable. This network is not affected by load. It has high impedance. Load is connected to anode circuit. The only thing remains, I have my antenna attached. What changes? Here we have the yellow line outside. It's the yellow first signal. You see frequencies. See? Nothing. They are equal. 544. My hand is near. And it goes around 539. What's going on? I introduce additional capacitance here. So inertia of this contour is greater, so resonance frequency lower and frequency of first signal goes down. Now, I have first signal and second signal. Put them on a resistance matrix to get a sum of them. To get sum of them, 1 second, we will see sum of them. More wires for the double wires.
Basically, you just discharged the capacitor and it was charged once again by another one. That's what.
Yeah, it swings like pendulum.
Oh yeah.
Capacitor charges, coil energy, let's say discharges. And the next moment charge of the capacitor full charge and it gives back energy to coil. Let me get some of them. Second, I'll make it more visible. Idea, let's say we can represent the first one, like maybe, okay, it's more preferable to represent second signal as a projection of vector rotating with frequency omega 2. We can assume what this 9 sine omega t. That this line is a projection on imaginary axis of vector on plane rotating with frequency omega 2. First signal, I have a sum of them, is a vector rotating with frequency omega 1. Sum of them, what will be sum of them? The first one also is assigned let's say it's an angle theta. Summary can be represented as a square root of S1 and square plus S2 square minus, who know cosine theorem from the school? Yeah. S1, S2, cosine of theta. So actually this component is the multiplication with cosine of theta. But this theta, what will be this angle? What's a function beside this angle? Difference of frequencies, yeah? If we assume this one is standing, let's say omega 2 is 0. What will be this cosine? Under cosine, what will be theta? If this one is standing and this rotating with omega 1, theta will become an omega 1t, yeah? In general, it's something like omega 1 minus omega multiplied by time, yeah? So, if S1 equals to S2 max, we will get something like this, yeah? With amplitude S1 max plus S2, yeah? And the frequency of the difference of frequency. It's something like not a good actual, not an ideal drawing. It's more like this. But if there is a difference, we will see something like big one and small one. So the picture will be this one looks like absolute value of cosine. If they are not equal, if one stands, we have something like this, and it will go to 0. But this one not standing, it's also rotates. And then after some time, we will have this one. Okay. If we speak on situation when S1 much smaller than S max, we will see something like this, and some signal will be something like this, field with the high frequency. This borderline resembles cosine of, and inside filling is an original frequency. What do we see? They are not equal. See, it's closer to harmonic scale. In different time scales. We have a nice peak voltage. Beat signal. Huh. Nice toy, isn't it? The last step, if we would like to get a sound, we need something non-linear. If we would like to get a sound, we need a so-called detector, amplifier, speaker. Because we need to separate the border line. 1 second, I will. This is scope. 1 second, I will reassemble. You unhappy, you unhappy. Okay, signals what goes to amplifier. It has a DC component and AC component of the borderline. Bit disturbed, capacitor is bit too big. Should be smaller, but not important. What's important? We saw one of the 8 examples of two signal motor effects. Example of two signals. What's the theory behind it? Can we take a deeper look? First, let's say it's a kind of umbrella theory covering all such effects. Where's my block? Before going to idea of two signal, we need to know one theory. It connects signal, say spectrum, with its energy. Let's say we have one signal and we connect the signal to the 1 ohm resistance. Of course it will hit with some energy. Let's assume what we can perform a Fourier transform on this signal. And we got signal spectral function. Can we tell something about this heat energy? It's definitely if P is U squared divided by R, yeah? So we need to, let's say, account all powers. So it will be sum of all signal squares. Why there is no resistance? Because I took 1 ohm. Easy. Easy. But I can also write it in a form like this. As infinity to infinity signal multiplied by 1 divided by double P multiplied by minus infinity to infinity omega. I need to write omega here. A power dot omega t. The omega should close and write as a time. What's this? What's in a square parenthesis? It's an inverse Fourier transform, and it's equals to signal. So I replaced one of the signals as its inverse Fourier transform from the spectral function. If we change sequence of integrals, we will get our energy as 1 divided by double P minus infinity to infinity spectral function the omega minus infinity to infinity now the integral our signal F power. Nice? Nice. What do we see? Two strange formulas. This one, okay, it says integration spectral function, but what about this one? Something familiar, no? It's a spectral function, but with minus sign at frequency. It lacks a minus here. So, it's a spectral function, but on negative frequency. Or conjugated spectral function. Who knows what means conjugate? Conjugated. Can con of something function. When you change a sign of imaginary part of complex number or alter a sign at complex part, idea with spectral function, it's symmetric. Relatively zero or DC point, always spectral function from minus frequency is a conjugated from positive frequency. So we have spectral function multiplied by conjugated spectral function. Meaning, as a result, we will have 1 minus infinity to infinity meg the omega. We will have square of absolute value, maybe. is better, we will get square of absolute value. Energy, infinity to infinity. Square signal equals to 1 against t. From 0 to infinity, its spectral function, absolute value square, d omega. Name of this theory is a Parseval's theorem. Parseval's theorem connects signal spectral function with signal energy. On a basis of Parseval theorem, special characteristic named a spectral density of energy is introduced. It's 1 against P squared. Its name is spectral density of energy. It tells us energy distribution as a function of frequency. When one day you will make RF circuits, high frequency circuits, where we speak on gigahertz, it's quite hard to say where is the current or voltage in the wave. Everything here is, let's say, everything is wave. And if everything is wave, you can say current or voltage, but you can. You're missing everything. It's a spectral density of energy for gigahertz, terahertz, and so on signals. It's quite hard to speak of current as a function of voltage, but energy always remains. Okay, Parseval's theorem, we saw it. And now let's look. We have same 1 ohm resistance, S1, S2. Both are time function. What if I connect not one signal, but 2? Okay. I have 2 signals. So I have, let's say, GS1, a result of Fourier transform on the first signal, and I have complex S2 as frequency as a result of Fourier transform on second signal. Good. No voltage. No voltage, no. Yeah, it's the because what's the idea? When valve is cold, its parameters a bit different until it heats up, and later it's dependent a bit on voltage, because lamp conductance is dependent on voltage, and there is also dependence on temperature of coil and on condenser. Wait 1 second. I'll show one funny trick. I have this demo condenser. This will become hot, and 1 moment I'll put on, give me some space, ground, just wait for ground. Okay, ground. Object. Just 1 second. Oh, silence. What changes? Oh, it's not conductive. Frequency change. But why? No, it's a book. Yeah, see, it's electrostatic field inside capacitor. This capacitor is connected in parallel to the resonant conductor. What's from physics, capacitance? What's inside capacitance? Who remembers physics well? Yeah, in capacitance formula. Flat capacitor from the physics. No. Not enough. Carpet is not. Yes, permeability. Yeah, permittivity. Let's say it's a constant characterizing media or insulator between. Paper has a greater permeability than the air. So I have a 0 frequency for the air. If I put paper, we have epsilon 0 epsilon. Paper has a greater epsilon. This means what capacitance increases. And frequency decreases and difference of frequency increases. There is something here. Where is my Theremin? Everything disappears in this faculty. I don't know where it is. The same effect. So, what I'm going to write, I have two signals and the spectral functions. Can I go back to my theory? Yeah, I can go back to my theory. So energy will be minus infinity to infinity, first signal plus second signal, square, and I need to account it's in infinite time. But it also can be written as says by Parseval theorem, like this. First signal spectral function plus second signal spectral function, take an square of absolute value and account for all existence. It's because Fourier transform is linear. Transform of the sum equals to sum of transforms. I need to do something what I knew. It's very simple. It's a very simple complex mass plus of omega multiplied by one conjugated plus conjugated. This knowledge helps me. Now I will write a long formula. Is it clear how I get it? Yeah, very simple complex mass. Now we will see a long formula. Oh, minus infinity to infinity what? First signal as a function of time plus minus infinity to infinity second signal in time plus this should be square by the way. Double minus infinity to infinity time s2 time big time. Yeah, this good equals to 1 divided by double P. And here we'll go from minus infinity to infinity, GS1, GS2. This is 1, this is conjugated, plus, again, minus infinity to infinity. Second, first, GS2 from frequency, GS2 from frequency, the frequency plus, we need again integrate in infinity. Mergings, this will be GS1 from frequency, GS2 conjugated as a function of frequency plus conjugated, not conjugate, GS2, GS1 conjugated as a function of frequency, frequency. This one also function of frequency. Yes! Yes. Yeah, here is my long formula. Long formula. So, let's take a look on the long formula. What do we see? A lot of absolutely unclear symbols. Yeah? Something long and unclear. Look at this one and this one. Something familiar? It's a Parseval theorem. They are equal. Same thing with these two. They are equal. They are nothing else as a Parseval's theorem. What does this mean? What green one equals to this. Yeah? Do you agree? Who's not agree will be executed in place. Signal itself, its energy of the signal, representation in frequency space. Signal itself, its energy in frequency self. What's this? Huh? Infinity to infinity as time equals to 1 against 4p minus infinity to infinity GS1 from omega GS2 conjugated from omega plus GS1 conjugated as a function of omega, GS2 not conjugated as a function of frequency, d omega. What's this? Any ideas? This is energy of mutual effect. The mutual energy. Or energy of interference. Take this as a function of frequency and you will get interference energy by frequency. Something familiar, no? Light interference. Huh? If there is interference, how do we call light sources? Coherent, yeah? What is in course of physics? Coherent light sources producing an interference. What? Here we got a theorem known as Relay theorem or Relay-Parseval theorem. It describes mutual effects or interference of two signals. If this energy is zero, signals are absolutely independent. They can coexist in one media without any interference. If it's not zero, they are coherent and will produce what? An interference signal on the which frequencies? One set will be on a see what we got here. Multiplication of product of spectral function. So we will have one set of interference signal on the frequency, let's say difference, and another one on a sum. If we have two signals or many signals in sum, we will get an interference signal with its own spectrum. Can we see? Oh, wait one moment. I'll put voltage. I'll need some signal. This one goes to amplify. And we should go this one. It's easy here. Okay. Possible. Yeah. Can we see a red line? 1 second, I will switch. Do you see red line? Come on, take a look on the red line. Frequencies are equal, no mutual effect. Frequencies are different. And what do we see? Our base signal and near 2-bit tones. time function, multiplication of two cosines, frequency function. Who learned trigonometry in school? Multiplication of cosines. Multiplication. What produces multiplication of cosines? Cosine alpha, cosine beta. What will yield? School trigonometry. Not 1/2 cosine alpha plus beta, cosine alpha minus beta. We will have, this one will yield us, we will have cosine alpha plus beta and cosine alpha minus beta. Two frequencies. Here they are. 1 and 2. See, they come closer. Oh. Large distance between them. Such kind of signals, like this, actually are very popular. Extremely popular. Why? Because they can be used for information transfer. And they are used for information transfer. If, say, I have something like, okay, let's do O cosine omega 0 time. I can attach it to antenna. It should be isolated antenna. What will happen? If frequency is high enough, electromagnetic wave, it's like leaves antenna and distributes in space. Remember the Tesla towers? Who didn't hear about Tesla tower and his idea of distributing wave around Earth's conducting core? Tesla believed what Earth's core is conducting. Remember? Yeah, giant. I have a tiny model of my own. Yeah, the idea was ground wire. On the ground, and this sphere, hemisphere on the top of tower should excite oscillation in capacitance between conductive Earth core and some higher spheres. It never worked. But idea, what electromagnetic wave can be. Ground is conductive, but there is no metallic core, and the key idea of wave propagation works with different.
There are many theories. Some say that
for his idea that needed to build something, I don't know, is it completely dismantled near Chernobyl? It was subject to GA.
yeah.
Giant array, the bigger one was receiving antenna with this giant set of dipoles. Helmholtz dipole to excite a wave in the space. We need Yeah, it's for location behind the visible line of horizon. It's used directed, let's say, pulse of wave reflected from a ionosphere and then returning back. Yeah, and most it can use second reflection. First reflection from ionosphere, from Earth, and another jump. Yeah, it was intended to use 2 jumps, but required a megawatt, real megawatts of energy. Yeah, that's why it was near the nuclear power plant. And was heated by emitters all around because the peaks occupied an amateur radio frequencies, the range. Now someone else at a 7 megahertz stable signal of the radar. Okay, the idea, if you have a high frequency oscillator and antenna, this wave will propagate. But propagating wave is nothing. Or you can send the high frequency signal onto cable and it will propagate. The key moment, propagation of high frequency, yes, first transmitters use just signal, no signal, the telegraph mode, this spark transmitters. But later, idea, I have O max cosine omega 0 time plus V0. It's a carrier signal. This will be megahertz or even gigahertz. What can I do? I can use amplitude. I can use, let's say, I want to transmit a signal. My voice. It's information. Information. Useless, but information. I can use 1 plus modulation depth cosine omega 0 and plus V0. Extremely popular thing, and first one used real. It's an amplitude modulated signal. When transmitted information is, let's say, packed or encoded in signal amplitude. Inside central line will be carrier, and this one possible will be the voice. The amplitude modulation was extremely popular and remains in usage because receiving part is very simple. It requires a very simple equipment on the receiving side. You can spread simple receiving, something like Falkenfanger. Heard some? Who heard about Falkenfanger? People's receiver. In German, during times, so-called Goebbels phase. Very simple receiver, but produced in millions. Was spread all around. First receivers were one resonance contour, one very basic diode from Galen. It was unstable. When you want to hear something, you need to find the point of semiconductance so it will work as detector. And earphones. And you can hear voices of King. Simple equipment. It's still used now. What also can be done? Problem with amplitude modulation, low quality of signal. It's good for voice, but signal is not on the high-end quality. Another idea. You can say maximum cosine of 1 plus omega 0 times plus phi 0. What it will be? Signal is encoded in frequency. Letters FM are familiar. Frequency modulation. So transferable information is encoded in frequency. PM will use phi 0, 1 plus modulation index. You can encode it in phase and it will phase modulation. You can, for digital, for sound or analog, only one can be used. For transfer of data, you can use amplitude and phase, and it will be quadrature modulation. You can use frequency keying, when one frequency is for 1 and one for 0. Frequency keying, it was the first technique to transfer the digital information safely. Quadrature, amplitude, phase. Frequency keying also for high compression rates, Q-arm, quadrature amplitude modulation are used. They select all complex plane on a smaller areas, and each area corresponds to quadra bits or maybe even 8 bits of code. Okay, let's see. Let's go from the simple to more complicated. We can look on amplitude modulated signal. This one, be a signal, is very close to amplitude modulated signals. Maybe I'll get the source, good source, better source to show it in more stable way. 1 second, I will clean some space. I will clean some space. This one definitely will not need. Something. I need some place on my table. more generators, forgot of generators. Dum 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 dum. Oh, signal. Signal, 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 signal. Yeah, I got signal. Okay, now I have a signal in cosine omega 0 time at 20 kilohertz. What should I get on a red line? Red line is a result of Fourier transform on this signal. What should I get? Cosine and 20 kilohertz. What should I get? In theory. Huh? What should I get as a result of Fourier transform? Del of omega minus omega 0 or ideal thin line at 20 kilohertz. I will not get ideal line come on. Yeah, I see. I saw a second color. Here's my signal at 20 kilohertz. Scope believe it's 9. Here is 20. Signal bit not ideal, it's a second harmonic of my signal, this one. And now, I will use second signal being as cosine omega t at 400 Hz. In this way, I will use 1 plus modulation index as cosine omega t cosine omega 0 t. What should I get? I will use for ideal 400 Hz signal to as a key for modulation. This in this form. I will use this form. What should I get? Cosine multiplied by cosine. Watch it. M is 0. Modulation depth is 0. I'm increasing the depth of modulation and I need to modulation 0, 1 and only 20 kilohertz. I'm increasing. See, I'm transmitting. Nothing transmitted. I'm transmitting 400 hertz. You see this? Can you see this? Central lobe. A central band. Not containing, it's not transferring any information. %100% depth of movement. This parameter is called depth of modulation. Now it's near 100%. 9 meters show 9. I have 90% depth of modulation. And what we see this side bands. For ideal AM signal, this sideline is time inside feeling is a cosine with omega 0 and its spectrum function looks like this. Central line at omega 0 m by half omega plus omega 0 omega minus omega 0. This is not better I write omega 0 plus omega and omega 0 minus omega as max cosine omega. Oh, nice. For amplitude modulated signal, we have a central band, or central frequency, at the frequency of Kelvin, not transferring anything. And two sidebands. These things are called sidebands. Sidebands are symmetrical and they contain the same information. Can we make a small experiment? More wires for the gap of wires. More wires for the gap of wires. More wires for the gap of wires. Signal from my large generator. Large generator. Why so strange? This will be fine. So I need to put 1/3 and 1. Familiar signal. Have you saw something like this? Is the signal familiar? Yeah, we saw it multiple times. We saw it multiple times. So, what kind of this one is fine. What kind of spectrum contains such signal? One of the bass frequency, 1/3 of the third, 1/5 of the fifth harmonic, yeah? 1/3, 1/5, 20%. Familiar signal. What's the base frequency of the signal? Can you see? 400 Hertz. Now I will use the signal for amplitude modulation. Can I connect it to the second channel? You see it? Measurements for the second. (200 kilohertz). Sorry, 20 kilohertz. You see, it's a sign of 20 kilohertz modulated or controlled by 400 hertz signal. 20 kilohertz carry 400 hertz. You see? And now what's about what's about its spectrum? Can you see a red line? What do we see here? Where is my measurement line? Where's the central frequencies? 20 kilohertz. And what about sidebands? No sidebands. Sidebands with the signal. And we got 20.4 What frequency should be here? What frequency should be here? Omega 0, 20 kilohertz. Omega 0 plus 1 omega. 20 plus 0.4. What's the next one? Rectangular signals contains 1 omega, 3 omegas, 5 omegas. What's the frequency of this one? It's omega 0 plus triple omegas, or 20 plus 3 by 0.4. and it will be, it's an IQ test, 21.2. Scope shows 21, yeah, 0.2. And the next one, what will be frequency for this one? Omega 0 plus 5 omega. And on the other side, what's the frequency of this one? 20 minus 0.4. It's omega 0 minus omega, omega 0 minus triple omega, and this one will be omega 0 minus 5 omegas. So we see spectrum of original signal, but spread symmetrical relative to the carrier frequency. In general, it's not energy effective. This thing contains no information at all, and these two are symmetrical, they have the same. If you, let's say, remove from the transmitted signal central band, you will have so-called balance modulation. Because central band is useless, it can be removed from the signal. It will be balance modulation on transmission with rejected carrier. But at a reception point, because you don't know the sidebands are, you need to recreate it from the local, so-called heterodyne, from local generator. It can be done, we can speak it later. Some systems periodically transmit a so-called pilot tone to give a signal to synchronize with. And this one, sidebands, actually to transfer anything, you need to transfer or transmit to someone only one sideband. Signal transmitting this will be USB upper sideband. And transmitting this, only this part is a lower sideband. Detection. I need detector. 1 second, we'll see. Receiving end is moment. I'll use one of the I need to switch somehow. No. it's not good because it's not good. High input resistance. One moment. Help with the signal is on the way. Yeah, this way is much better. I applied a circuit, I needed some resistance. A circuit like this. This circuit, this diode, what is that? It separates, repeat disturbance, it separates a border line. And you see, this one is detected signal. It's what our client, our receiver should get. Big disturbance, isn't it? But in general, something cool. This one. Oh, here it is. Here is spectrum of received signal. You can see DC component, our signal, but it also, it's set, but it contains also one moment. Hertz, I need it. Where is it? 800 Hertz second harmonic. This one is good. It's a third harmonic of my original signal. This one is parasite, second harmonic. Also fifth harmonic. Why? Because of detection scheme. With diode. It's with such technique, received signal will contain odd harmonics. If you want undisturbed, you need something bad. Better technique is called synchronous detection. But synchronous detection requires local source of carrier frequency. Local generator synchronized with a carrier, or carrier transmitted directly. But anyway, that's how all the receivers work. Do I have time? No, I don't have time. So you will not see all the receiver with the real signal. Okay, that means what it's enough for today. Next time will be more.